Hello everyone, welcome back to Deeksha Karnataka YouTube channel. Today I am going to discuss very important questions from the chapter Current Electricity. And in my last video I received a lot of comments saying that sir, 2024 paper was difficult, 2024 paper was difficult for COMEDK, so add some difficult questions. So first of all I tell you that 2024 paper was not difficult. Okay, I have analyzed the paper. There are two shifts. I checked the first shift initially. First shift was relatively easy. Second shift had some uncommon question. I will not say difficult, but uncommon question. So many students face difficulty answering some uncommon questions, but we will today's session in current electricity chapter I will be solving few 2024 questions as well. And don't be afraid too much about the level. Okay, 2024 someone told you that 2024 paper was difficult, that does not mean that 2024 paper was difficult. That means they lacked preparation. Say generally COMEDK happens in two shifts, morning shift and in the evening shift. Evening shift paper was slightly offbeat, so that's why some students felt that this is difficult. Not at least for physics. Physics was as I said, is little bit offbeat but not difficult. Okay, other subjects may be so, chemistry and maths, but physics was not difficult. Some offbeat uncommon questions came, but that is answerable if you just spend a little bit time, maybe 10 seconds extra on those questions, you can answer them. Rest of the questions were relatively easy as well. Now so COMEDK overall difficulty is not super difficult. So if you are thinking that COMEDK will be difficult, don't worry too much about difficulty level. The resistance of the wire in a heater at room temperature is 65 ohm. When the heater is connected to a 220 volt supply, the current settles after a few seconds to 2.8 ampere. What is the steady temperature of the wire? So first of all, what we have to do, the initial resistance at room temperature 65 ohm is given. Okay, and after you send some current through the heater will heat up and it will give you some current 2.8 ampere. So you have to find the final resistance of the wire. So final resistance of the wire will be its initial whatever the voltage that you have applied and the current. Okay, so it will be 7 and there will be 4 5s are 0, 55 by 0 by 7. Now you can take this 55 to be very close to 56 and you can cancel this as to be 80. So we have to do a lot of approximation in this question because the data is not cute. So let's see how can we answer this question. Okay, now next is what is the change in this resistance? Change in this resistance is RT minus R, that is 80 minus 65, that is 15. Okay, 15 ohm is in the change in the resistance. Now we know that the change in temperature is given by change in resistance divided by initial resistance times alpha, right? This is the formula. Now what is delta R? Delta R is 15, R is 65 and alpha is 1.7 into 10 to the power of minus 4. Now what we will do, a little bit of cheating and we will say that this 1.7 and this 15 are almost same and we will cancel them and we will leave a 10 over here. Why 10? Because 1.7 only 15, so 15 means you have to add one extra 0, so cancel the decimal, so you will get 10 to the power of 5. There was 110 over here and 10 to the power of minus 4 by 65. Okay, so now we have to do the mathematics again. 1 to 100 into 10 to the power of 3. Say this is the easiest one, right? This will give me some value greater than 1, so I will try to do that. 13 5s are 65 and 20. Okay, so it will be 1.7770. Okay, let's change the approximation because it will be slightly different than what we are doing it. So let's change the approximation, because we have increased this value to 80 because it is slightly less than 80. So what we will do, this 15 number we will consider this is closer to 13. That will help us a lot. So 5 13s are 65, and 1.7 into 5 is basically 5 ones are 5, 8.5. So we will get 10 to the power of 4 divided by 8.5. So it will be now 8.5 we can approximate this to be. A lot of approximation is involved, so correct approximation will give you a correct answer. So it will be 2 425 is 100, 2500, and it will be 1250. So 1250 is the change in temperature, approximate value in the change in temperature. So 1250 means correct answer will be 1258. We have done a lot of approximation. This is not an ideal question, but this question came in 2023. So this kind of question might come, which is not actually very good question. Now let's see this question. Two bulbs when connected in parallel to a source takes 60 watt each. The total power consumed when they are connected in series with the same source. So first of all, when they are connected in parallel to a source, take 60 watt each. 60 watt each means what? They are having the same resistance. If they are connected in parallel and both of them are taking the same power, that means they have the same resistance. Okay, so resistance is R, here also R, and suppose the voltage is V, then what is the power taken by any one of them? It is V square by R. That value is given by 60. So V square by R is 60, right? This is also V square by R, this is also V square by R. Now when you connect them in series, okay, what is the total resistance? Total resistance is R plus R. So what is the current in the circuit? Current in the circuit is V by 2R, right? Now what is the power consumed by this? Power consumed by this is I square into R, that is V square by 4R square into R, that is V square by 4R, right? So it will be 60 by 4, that is 15 watt each. So each of them will consume 15 watt each. So in parallel 60 watts, in series 15 watt. Okay, now next question. The IV graphs for two different electrical appliances P and Q are shown in the diagram. If Rp and Rq be the resistance of the devices, then Rp equals to Rq, Rp greater than Rq, Rp less than Rq, and Rp equals to Rq by 2. Now this much information is not given, whether they are equal or half or not, but rest we can find. How can we find that? We know that V is equal to I into R, right? So if we keep the current constant, okay, if we keep the current constant, then V is directly related to resistance. So how can we keep the current constant? To keep the current constant, we have to draw a parallel line from the I axis. That means this line, along this line current is constant. Now as you can see, this is voltage Vp and this is voltage Vq. Now which one is bigger? This one is closer to origin, so this means this is smaller, this is obviously bigger, so Vp is greater than Vq, so Vp is greater than Vq. That means Rp must be greater than Rq, okay, because it is directly proportional. So Rp must be greater than Rq, so correct answer is option B. Now if you are preparing for Abhyas, that is if you are preparing for KSET exam or COMEDK, then you should know that Abhyas KSET test series is already ongoing and the price for this is 1498. Here you will get 35 complete mock tests having part tests as well as full length test along with their complete video solutions, and COMEDK crash course we will start very soon, and it is available for purchase at a price of inaugural price of 1999. Okay, here you will get 12 mock test, 4 part test, 8 full length test, complete syllabus coverage, 5 previous year questions, live doubt solving sessions, class notes and recorded revision videos. Okay, now let's continue with our session. A cylindrical rod is reformed to half of its original length, keeping the volume is constant. If the resistance before its change were R, then the resistance after the reform, so length is half. So what will be the new resistance? New resistance will be half square into R, that is R by 4. If resistance is doubled, then it will be twice, so 2 square into R, right? So always the change in the length square times the old resistance, the new resistance will be R by 4. Next question, 5 equal resistances 10 ohm are connected between A and B as shown in the figure. The resultant resistance is. This looks a very tricky question, and also it might appear that almost not solvable, but this question is very simple. Only thing that you have to remember that current always flow through the path where the least resistance is offered. If multiple paths are available, it will always flow through the path where least resistance is available. So as the current starts from here, it sees that there are two 10 ohm, that is this path is 20 ohm resistance, whereas this path has only 10 ohm resistance available to it. Because this is short circuited, that means the current will flow through this 10 ohm and it will reach over here and everything will pass through this. Very small amount of current will pass through this 10 ohms, so you can ignore them. Okay, you can ignore them. Only current will pass through A to B via this path. Okay, so the effective resistance will only be 10 ohm. So effective resistance will only be 10 ohm. Next, this question is from 2024 paper. So as I said, paper was slightly odd. So let's see why I am saying this is slightly odd. There is a capacitance connected in the circuit. Figure below shows a network of resistors, cells and capacitor at steady state. What is the current through the resistance 4 ohm? So you have to find the current through this 4 ohm resistance. Okay, now here this capacitor in steady state means it is not conducting any current, it is fixed. Okay, that means you can simply if there is a capacitor connected in a circuit, you can ignore that branch completely, because capacitor does not conduct any current in steady state. Okay, so no current is flowing through this, so you can simply ignore this and you can ignore this resistance as well. Okay, so only circuit that is left is this one, which is a very simple one. So if you know what is the circuit, then you can find the current. Now here, first of all, we will use KVL in this first single loop. Only one resistance, only one battery, very easy. So if the current through this is I, then 2I equals to 6, right? So I equals to 3 ampere. So current through 2 ohm is calculated directly. Now current through this is say I1. Okay, current, same current will pass here, same current will pass here as well. Okay, so if the current passes through this is I1, okay, then we will apply the logic that this current is coming over here, 3 ampere current passing through this, so 3 plus I1 is passing over here, and then I1 coming here, I and 3 is going back here. Okay, now what we will do, current through this will remain, current through this resistance will remain 3, okay, no matter what. Now you have to find this current I1. How to do that? We will consider this loop. Okay, this current I1 is absolute, we have calculated that. Now I1 we are trying to find. So I1 into 1 plus I1 into 4, that is 4I1, plus 6 volt, 2 into 3, 6, and here both the batteries are sending the current in the direction that we have considered, so they will add. So you will get this as 3 plus 2, 5. Now here 5I1 equals to 5 minus 6, that is minus 1. Now don't worry about this negative sign. Negative sign means the original direction that we have assumed is opposite to that of that. So that means current I1 is passing in this direction. That's it, nothing else. Now I1 equals to 1 by 5, 1 by 5, that is equals to 0.25. So 0.25 means the correct answer in this case is 0.2, right? So even though the problem is tricky, but it is not answerable. If you know the tricks, you can solve it quickly, not super difficult. Okay. Now next question. Now this is one of the another previous year question which is very tricky, not 2024 but in the past. Let's see. Eels are able to generate current with this. The story is long, the problem is simple. Okay, eels are able to generate current with biological cells called electroplaques. The electroplaques in an eel are arranged in 100 rows. 100 rows, this is called rows. Okay, each row stretching horizontally along the body of fish containing 5,000 electroplaques. The arrangement is suggestively shown in the figure. Each electroplaques has an EMF of 0.15 volt and internal resistance of 0.25 ohm. The water surrounding the eel completes a circuit between the head and its tail. If the water surrounding has a resistance of 500 ohm, the current an eel can produce in water is about. Now here there is a shortcut formula that I am going to teach you. What is that shortcut formula? When say n number of cells are connected in series and m of them are connected in out of them are connected in parallel. Okay, so both series and parallel connection both are there, then current in the circuit is basically given by m n epsilon divided by whatever is number of parallel combination, that parallel combination times the resistance, big resistance, plus whatever is the number of series connection times the small resistance, right? This is the formula you have to remember. This is number of series, this is number of parallel. Okay, now mn is here 100 rows. 100 rows means this is the number of m, so m is 100, n is number of series, that is 5,000, and each of them has a EMF of 1.15. Okay, now they have some internal resistance as well. Internal resistance is 0.25. The external resistance is 500 plus the internal resistance is 0.25 into 5,000. So 5,000 into 0.25. Okay, now you can take 100 common from each of them and you can cancel the 100. Okay, that will reduce the values, right? Now 5 into 0.5 is 5 into 0.5 is 125, right? 1.25 times 1000 is 1250 divided by 500 plus some 12.5. Now 12.5 we ignore this term, this is very small number compared to 500, so we will use this as 500 only. So zeros will cancel, you get this will be, I made a mistake, there will be one less zero over here. Okay, let's not solve it like this, we can solve it easily. So we ignore this term, so 5,000 into 0.15 divided by 500, so 500 you can cancel, you will get 10, so 10 into 1.15 is 1.5 ampere. So current will be 1.5 ampere, which is a very huge current considering eel is a very small fish, but still it can produce a very high current and it can shock you momentarily. Now let's see this question. This is very interesting question. In the part of a circuit shown in the figure, the potential difference between the point G and point H will be. So point G and point H will be, so here the current is flowing here is 2 ampere, okay, and here the current going out is 1 ampere and 3 ampere, okay. So this is given. So if this current is 2 ampere, okay, we have to find what current is passing through this one. Okay, so this current 2 ampere passing, so this is passing through this battery, so this same current will pass through this as well. 2 ampere current will pass through this resistance as well, okay, because of conservation of charges. Now here the current after passing through this, now you can see that 1 and 3, so total current which is going out from here is 4 ampere. So if total current going out from here is 4 ampere, that means someone else is supplying that current, and that current is getting supplied from this, that is another 2 ampere. Okay, so 2 ampere coming from this side, 2 ampere coming from this side, they are combining and you get current 4 ampere over here, right? So now this part is not required, only this part was required to identify that there is 4 ampere and the current through this is 2 ampere, right? Now we will take a loop. We will what we are trying to find, we are trying to find Vg minus Vh. So we will take this loop. Anything we are going in this direction will be positive, anything going in the opposite direction will be negative. So 2 into 4 Kirchhoff's voltage law, right? 2 into 4. Now here this is going in the direction of current, so on the right hand side it will be 3 obviously, and then will be 2 into 2, that is 4. And here we are going in the opposite direction of the current, so it will be minus 1 into 2, and here will be 3 plus Vg minus Vh. Okay, so this is what we are trying to find. Now this is the formula. So 8 plus 4, 12, 12 minus 2 is 10, so 10 equals to 3 plus Vg minus Vh, or Vg minus Vh equals to 7. So this is the answer. So answer will be 7 volts. So even though this is a tricky question, you can still answer it if you follow the steps. 3 bulbs, 220 volt, 40 watt, 60 watt, 100 watt are arranged in series with the source. The maximum light is obtained from. So you have to understand that power is inversely proportional to resistance if voltage is constant. Okay. Now here they are connected in series. So in connected in series means voltage is not constant obviously. It is constant. P is equal to I square R, right? So if current is constant, then power is directly proportional to resistance. Who has higher resistance is basically 40 watt. 40 watt will have higher resistance compared to other bulbs, other wattage, okay, because resistance is V square by P, okay, because power rating is same for all the bulbs. So resistance will whoever has small power will have higher resistance. Now power dissipated in any of the bulb is basically given by I square R. Now I is constant in this case. Series connection means current is constant, so whoever has higher resistance will have more bright, right? So in this case, as you can see, power rating is same for all the bulbs. You can calculate the resistances for individual bulbs, calculate the power, does not required here. Only idea that you need to understand that resistance will be more for low power and resistance will be less for high power. Okay, so that, and from there you have to understand series combination. So in series combination means whoever has higher resistance will glow faster, so 40 watt will glow more in this case. Not required any mathematical calculation. Point out the right statements about the validity of Kirchhoff's junction rule. It is based on conservation of charge. Junction rule, conservation of charge, no need to look for any other points. Next question, if P equals to Q equals to R equals to 10 ohm and S equals to 20 ohm, then what resistance should be joined with S to balance the Wheatstone bridge? Okay, so here we have a Wheatstone bridge. Very interesting question. This is slightly trickier than normal questions. Okay, P, Q, R, S. So this all of them are there is a galvanometer. So all of them are 10 ohm, right? 10, 10, 10. Okay, now this value say X. Okay, originally this it has a resistance of 20 ohm. Now originally this say X. So what is the value? 10 by 10 equals to 10 by X. So you say that X should be equals to 10. Okay, so the total resistance of X should be 10. Now how can we have 10 where originally it is already 20 ohm? So we have to reduce the resistance. How can we reduce the resistance? Is there any negative resistance? Negative resistance does not exist. To reduce the resistance, what we have to do, suppose this is a 20 ohm, we have to connect another 20 ohm in parallel so that the effective resistance becomes 10 ohm. There is only one way to reduce the resistance in circuit theory, that to apply a parallel resistor. Okay, so join a resistance 20 ohm in parallel with S. So option C is correct. Next question, the current through a conductor is A when the temperature is 0 degree. It is B when the temperature is 100 degrees. The current through the conductor at 220 degrees Celsius is very interesting question. Okay, they are talking about currents and nothing about resistance. So you have to remember that voltage is constant over here. So what is the relationship between resistance and voltage? So resistance and voltage, V is equal to IR. Okay, so I or you can say that R equals to V by I. Right, now for simplicity we will consider that voltage is 1 volt, so 1 by I. Okay, this is the simplicity we will use. You can take any other value, but mathematical value helps us to solve the question faster. So because it's a constant, we will take this constant as 1 to solve the question quickly. So initially what is the resistance? Initially the resistance was RA is given by 1 by A, right? Temperature was 0 degrees Celsius, and at 100 degrees Celsius, what is the resistance? At 100 degrees Celsius, the resistance is 1 by B. Okay, now you have to find the current through the conductor at 220 degrees Celsius, but before that we have to find what will be the resistance of the conductor at 220 degrees Celsius, right? So first we have to calculate what is alpha. Alpha is basically change in resistance, R high resistance minus low resistance, divided by low resistance times delta temperature. Okay, so RB is 1 by B minus 1 by A divided by 1 by A into 100, right? So it will be A by B. Let's leave this like this. Okay, no need to calculate it. Now the final resistance, that is resistance at 220 volt, say RC, is basically given by RA 1 plus this alpha value, that is 1 by B minus 1 by A divided by 1 by A into 100 times 220. Okay, now you have to multiply RA value is 1 by A, so you have to multiply that value. RA is at 0 degrees, so that's why we are using this value, right? So 1 by A, now 1 by A multiplied 1 is 1 by A. Now when you multiply this with this 1 by A will cancel, right? So you will get this will cancel, we can reduce this as well, we will get 5 and 11. So you will get 11 by B minus 11 by A. Okay, so that's why I said do not cancel it, do not try to simplify it, because this will give us RC directly. So what is RC? RC is, so we have a 5 also. So 5 AB is the LCM, and here 5 will be multiplied with here. So 5B plus 11A minus 11B. So it will be 11A minus 6B divided by 5AB. This is the resistance. Now what is the current? We are not interested in resistance, we are interested in IC. So IC will be V by R, so that is 1 by RC. V was 1, so 1 by RC, so the current will be 5 AB divided by 11A minus 6B. Okay, so 5 AB divided by 11A minus 6B, option C is correct. Little tricky question, but very interesting question. Now next, this question, which one of the following equation is correct for the electrical circuit in the figure? Okay, so here what they have given a circuit diagram, I1 coming over here, I2 coming over here, and there is an E1, there is an E2. Okay, and we have to find the relationship for resistance R. Okay, so we have to find the resistance for R. Now if you see that both current are coming this way, so this is either going this way and this should also go this way, right? Then only this current will be coming back over here and they will divide like this, right? Now, so what is the current through resistance R? Current through resistance R should be equals to I1 plus I2. Okay, current through this will be I1 plus I2. Three of the equations have R. Okay, only one does not have R, that has only E1, E2. Okay, let's see which one will be the correct answer. First we will try to formulate the equation using E1 and R. So E1 and R means this is the direction of current, this is going here, R into I1 plus I2. Okay, current coming over here, now a current coming back through R1, so I1 R1, same current should come back, right? So I1 R1, and that should be equals to E1. Okay, so obviously the sign, if you see in this case, this sign is wrong, so this is not correct. Now same R here, so if you see this one, E1 minus R I1 plus I2 minus I1 R1 equals to 0. So this is matching, so this is correct answer. We can check the other two also, but not required. We have found our correct answer. We don't want to waste time. We are moving on to the next question. The balanced Wheatstone bridge is shown in the figure. If P is made 11 ohm, then which of the following condition will not balance the Wheatstone bridge? So if P, you change the value of P to 11 ohm, so this one you change to 11, then how can you still balance that? Either by changing R or adjusting Q, right? So R increase by 2 ohm. So if you increase this 11, so 11 by initially it was 10 by 20, that is half. Okay, now 11 by 22 should also be half, so again this will balance it. So this is a balancing condition. Q increase by 10, so initially it was 10 by 20, now 11 by 20 should be equals to 110 by 200, so also it is also balanced. So this is also a condition of balance. S increase by 20. So if you increase S, so 11 by 20 is the new one, this is 100 by 220. Obviously this is not balancing, this is not the condition of balance, so option C is correct. Okay, next question. On increasing the temperature of a conductor, its resistance increases because electron density decreases, relaxation time increases, number of collision between the electron decreases, relaxation time decreases. So the collision is more frequent collision means relaxation time decreases, and relaxation time decreases means its resistance increases. So with this note, I like to end this lecture. Today we have solved a lot of good questions, and I'll be back with a new session very soon. Till then, bye.